I think it's almost pretty much about time that we get going. We have a lot of content to cram in an hour and a half, and it is the last thing on a Sunday, and I'm sure you all want to go home. And you know what they say about saving best till last and all that, so we'll get going. I'm Max. You probably saw my name on the list and thought, who decided to give them the longest name that they possibly could. I am a cloud engineer at Stack HPC, and today with...
Yep. And I'm Matt. I'm a tech lead at Stack HPC.
Yeah, so today we will be going through something we like to call a universe from nothing. We will be going through the various stages of how to deploy a Linux-based cloud using OpenStack, going from practically having just what is the equivalent to bare metal to having a fully deployed cloud, whilst also deploying various services and how to reconfigure them and deploy new services alongside that. But before we get started, there's a few things that we need to cover, just so that we can make sure that, you know, this is for either refreshers or for people who don't have as much experience. So we'll cover what we'll be covering today is available for all of you to try at home.
Yes, so you can see some links here. We also have these links at the end of the presentation, so no need to rush and write them down now. The lab we're going through today is publicly available on GitHub, as is everything we do at Stack HPC. We're fully open source. And the steps we're going to be going through are roughly equivalent to what is documented upstream in the KOB project. If you want to try this yourself on another day, you only need a fairly small number of hardware requirements. You could probably put this on a chunky laptop, or most of you probably have access to virtual machines. This is open infra after all. And make sure you have support for virtualization. I understand this is probably everywhere at this point.
And just a fair warning, we've been told on multiple occasions that the internet connection down here is very flaky and it can drop off at any moment. So let's hope that this connection lasts longer than the average French Prime Minister at the moment. So we roughly covered some of the things that we're actually going to go over, but in more detail, what are we going to cover? We're going to be covering what Collar is, Ansible and Collar Ansible, and how they tie in together with KOB and how we use all those tools together in order to go from having nothing but some bare metal to a cloud.
You'll notice here we have some italics on KOB config. This is to highlight that this will be the main project that we'll actually be using today. This is essentially an Ansible-based inventory with extra configuration files to allow you to customize everything that you deploy with KOB. And in our lab, the actual hands-on lab later today, we'll actually be going through every step to go through to deploy a cloud.
So no point waiting, and let's get going, and let's go straight into Collar. Collar is the service that provides us the tools for producing containerized production-ready containers for our OpenStack services, and they do more than just being able to help us produce these containers, but also helps us to deploy them. We personally like to deploy them on Docker, but they also works and can be deployed on Podman.
The way that we'll actually be deploying these containers is using Ansible. Ansible was a very nice piece of tooling for defining our infrastructure as code. This means that it will be ever repeatable. And Ansible also has a very nice feature of idempotency. So each time you run it, you should get the same result out of it.
And as we're all probably quite familiar with YAML, they are YAML workflows named as playbooks, very much like you would imagine in American football, because it's the strategy of how we want to deploy. So we have that Collar can provide the tooling for the containers, and we have Ansible that can have the wide reach, but they probably seem to be missing parts of each other that we could take advantage of, and that's where Collar Ansible comes in. Now, not to be confused with Collar or Ansible, it is its own separate thing altogether. It's its own entity, and it's the Collar container tools, but with the reach of Ansible.
Yes, so Collar Ansible is essentially a set of Ansible playbooks and inventories designed to allow you to deploy pretty much all of the OpenStack services as containers onto multiple types of hosts. And as it says up here, it's particularly useful for simplifying the life cycle maintenance.
But what if you're trying to deploy something on bare metal? And that is where KOB comes in. It is what provides the tools for enrolling bare metal into a control plane, and this is where we come in with the ability to manage not only the enrollment of bare metal into OpenStack, but also for the management of the hardware over its lifetime.
Yes, so it's essentially it's a wrapper around Collar Ansible, so it's extending the functionality to allow you to not only deploy services with Collar Ansible, but also configure your host ready to be used by Collar Ansible. It's similar to the OOO undercloud or MAS or XCAT.
So we have the ability to manage our infrastructure. We have the ability to define what it is that we want to deploy. However, we need to decide this whole chicken and egg situation of how do we actually go from having nothing and enrolling it into OpenStack. And we mentioned that KOB helps us do this, but primarily how so?
Yes. So this is using the service called Bifrost. Bifrost is a standalone version of Ironic, which we deploy in a Docker container using Collar Ansible onto what we call a seed host. So this is the single host that we can then grow an entire cloud from.
And just like it says, Bifrost, much like in Norse mythology, is this bridge which bridges the gap between bare metal and our control plane. But how does it actually differ from Ironic, and how does it actually solve this whole chicken and egg issue? Well, primarily, the issue is that when you want to enroll hardware on OpenStack into the cloud, you kind of have to have OpenStack already running. So how do you do that when you don't have any OpenStack running? This is where Bifrost comes in as its own standalone.
Yes, so Bifrost is a Ironic deployed in a container with some additional services also in there, like a database and some Ansible playbooks to handle the management of the bare metal nodes. In our use case here, we end up essentially deploying the majority of the control plane and most of the hypervisors using Bifrost. Whereas if you wanted to use the full Ironic, that would just be to manage potentially additional hypervisors and then on-demand bare metal compute.
Now, you may have just heard Matt cover the fact that we have some additional services on top of standalone Ironic, and it sounds all a bit familiar in the sense of, okay, what are these extra things that we have in there that help us deploy containers, or just a way to get OpenStack deployed onto bare metal? And it sounds a bit like what we previously mentioned, KOB. And you may be wondering, where does KOB actually come from? It actually, if we have a look at Collar on Bifrost and break it down to its initials and actually sound them out, we can have that it actually spells out KOB. It stands for Collar on Bifrost. And that's why we had the sudden turn going from talking about KOB and going straight on to Bifrost. But I think that's enough of the nattering on of the underlying tools that bring us to what we're able to use to deploy a cloud. And I think we should start prefacing what it is that we're actually going to do now that we can get hands-on in a second.
Yes, so I alluded to this right at the start. We're going to be looking quite closely at the KOB config. This is a separate project that's designed to be read and used by KOB to allow you to actually configure what you want your system to look like.
So, as highlighted in these images, this is the kind of directories that we will be working within, but in your actual lab environment, this is pretty much exactly what it's going to look like. You're going to be in your home directory, and you're going to find that it will have a deployment directory, and within it there will be some scripts and some other things, but for the purposes of where things live, we'll have a set of source code, and within that source code we can see that there'll be further 3 directories, one for Collar Ansible, one for KOB, and the other one for the KOB config. As previously mentioned by Matt, KOB config is where all of our changes will take place and where they will be being pulled from in order to then apply to our actual deployment. So then if we take a deeper look into KOB config, there'll be a whole miscellaneous set of files, and within that another subdirectory with etc, and within that 2 subdirectories, one for KOB and one for collar.
Yes. An important thing to note here is we are using KOB, we're not just using collar, so we will be making all of our changes in the KOB directory today. The collar directory is something that is generated on demand by KOB, so when KOB then calls collar Ansible, it reads from that directory. These changes are somewhat ephemeral, so just make sure you're making your changes in the KOB directory or they may get overwritten.
Yeah, and we will be covering a bit more detail as to how do we make changes to collar and where those changes will be made, and we will try and clear this up because it can be quite confusing as to why we go into KOB config just to go into KOB. There was another KOB directory before that. It will all make sense eventually, and it's one of those things that we will try and iron out because I think that was a big step for some of us when we started getting confused where to put things. But more importantly, why and how do we use KOB config, and why is it set up as such? It seems counterintuitive, but what it is allowing us to do is actually something that's really quite powerful. We can apply the changes by using KOB to drive the Ansible playbooks in order to apply our changes. As Matt said earlier, they are idempotent, and so whenever we want to make a change, we can make that as code, as infrastructure as code within our KOB config.
Yes, there's a few key features up here that I'd like to highlight. First up, you get fine-grained control of your deployments. You'll probably know that when you're running a production system, you don't want to be making your changes straight to production. So you may have another staging deployment alongside things. KOB config supports multiple environments, so you can essentially nest your configuration. So you have both a shared configuration for all of your environments, and then you can just have the changes for staging and production. This means that your any changes that you made can be very easily tested on staging before rolling out to prod.
And now if we have a quicker look at what kind of changes can be made within your KOB config, there are actually a few things that we can do, and depending on what it is that you want to change, these are where those can take place. So, as Matt said earlier, it is incredibly important to understand that all changes that we make will take place in KOB config etc KOB. Nowhere else will we be touching things. It's just in there. One folder. Let's all make just all our mistakes in one folder. A lot easier to debug that way. Or do what I do, make mistakes, ask him for help. He gets paid more than me, so that's fine. So we make those changes in there. Then depending on the changes, if we're making a change usually to the infrastructure or the setup of the infrastructure, those will be defined within YAML files, usually within that directory, or in some cases within subdirectories for the inventory, or as Matt suggested to allude to earlier, any environments. Then we can make collar Ansible changes, so these are usually changes that you want to apply to your services or service-related changes, and those will take place in collar.yaml. And yes, that collar subdirectory that you're seeing up there is a very different collar directory to the one that's in etc. If you would like to probably explain that a little bit more, Matt.
Yeah, so to boil it down, KOB's role is to first set up the hosts, so we have some high-level configuration files for managing the hosts. And then we have all the changes for collar Ansible within these collar named playbooks and directories. So it's hosts on the left and your OpenStack services on the right.
And then these are things that they can configure and what they actually can impact. So these are effectively, when being requested to make a certain change, these are kind of like the pointers to where those changes should be made. A lot of terminology can get lost between service providers and clients, especially when they say, we want something changed in our infrastructure. It's like, what is it? So if they don't tell us that, it's very hard to dictate where to make the change. But we need to actually focus on what are the very basic top-down view steps that we need to make to take in order to actually deploy a cloud. So we have to write our configuration. We need to give our cloud some sort of skeleton, a form that we wish for it to take. And because it can't just take the shape of whatever we hope it does unless we actually define what we want it to be. And as we previously said, this will take place in our KOB config.
Next up, KOB has support for configuring your physical networking. So these are your physical switches. Off the cuff, there's already inbuilt support for a few different vendors. I think there's Dell, Juniper, more. It all wrappers around the vendor-provided Ansible collections, so it's only a few lines to add support as well if you have a vendor that is not currently supported.
Then, as we were having a look earlier with the whole chicken and egg, how do we enroll a cloud into something that doesn't have OpenStack? Well, we need to deploy a seed, which then will contain Bifrost. And for the most part, there are 3 main steps that you need to do for every deployment. And that will include a provision that will mainly deploy an OpenStack, an operating system onto the node that you wish to then have OpenStack on. And then the host configure will then prepare the node for running containers as well as then running OpenStack services on top and any other configuration that you want on the operating system level. And then finally, service deploy, which will include pulling down any containers and then actually running those containers with the configuration that has been defined in your KOB config.
Then you come to deploy the big guns, the overcloud, your actual physical servers. And you might notice that these look very similar. This is because we try to reuse as much of the same playbooks as possible. So with a seed, it will be provisioning just one VM on one host to then bootstrap the rest of the cloud. With the overcloud, we use the same technologies to provision an operating system onto proper servers. And then we run through host configurations again. So this is setting up networking, this is installing packages, everything you need to be able to run Collar Ansible on the hosts. And then we do a service deploy, actually using Collar Ansible to deploy the containerized OpenStack.
And then finally, I think the most important step is go for a drink, recover from all the time and the late nights working on it. So what does this actually look like in terms of diagrams? Sometimes lists don't actually help us visualize what it is and what it looks like and what manages what. We've just thrown a bunch of names at you: hypervisor, seed, but this is what it will look like from a top-down view. So again, starting with writing our KOB config and then configuring our physical network, so then we have the ability to actually communicate with the rest of the racks.
Yes, then we deploy the seed VM. This is where Bifrost is hosted. So you see we first provision the VM, configure it ready to deploy Bifrost on there, and then Bifrost is running on the seed. This is the red one. And then we come to deploy the overcloud. These are the yellow ones. And it's through the same kinds of steps, but targeting overcloud instead of seed. And then finally, you might have on the grey, this is using the overcloud version of Ironic to actually deploy bare metal computes.
No, Matt, that's a beer. So, and this is what a visualization of what those various layers of the cloud would look like as they are spinning up and populating the servers as they come online. So as you can see, the first thing that comes up is the blue layer on top, which is the networking. And obviously without that, KOB and Collar Ansible won't be able to actually communicate with any of the racks, and therefore won't be able to dictate where to pull images in and run those services. And so without the networking layer set first, we can't do the rest. Then we get the seed online, and then the rest is as follows. But obviously the only one that needs to be done in that very specific order is the networking followed by the seed.
So bring it all together. What are we actually going to be looking at today? So we're going to be granting you access to virtual machines which already have some services running inside. So you'll be able to see when we're in there that we already have a seed VM deployed for you. This is mainly for time constraints. We only have 90 minutes today. So you'll have a seed already running Bifrost on there. Notably, the seed is also set up as a Docker registry, so there's already images pulled into your VM. We will also have turned off 2 more VMs that are going to be acting as though they are bare metal servers. They're actually virtual machines in this case, but you'll be able to talk to them as though they're bare metal nodes.
Then we will be bringing those online. We will actually be using an inventory discover so that we can actually find them. And then once we've found them, we'll inspect them. And once we've inspected them, we can provision them. And then we can configure. And once we've done that, we can install some services and get those running. And once we've got those running, well, we have a cloud. And why not test it out by deploying a VM right on top? So I think we've said the same set of instructions. I think it's time that we actually get on with it.
I agree.
So hopefully at this point everyone's managed to get themselves a VM, and I think it's time we get hands-on with it. So again, if anyone hasn't been able to get themselves the worksheet and then get themselves a VM, please do so now. We can obviously come back to it if people haven't, but it'd be quite difficult to catch up at that point.
Yeah, just to clarify for those who walked into the room on time rather than early, in the worksheet there are some instructions linking to an Etherpad. There's a list of IP addresses on there. If you can just put your name next to one, cross through it so the other people know you've claimed it, and you'll be able to run your machine from there.
So the general outlook of what we're going to be doing with the hands-on section is we're going to be doing some quick housekeeping and pre-checks, just because of how we have configured this VM to look like, well, how the VMs have been configured to look like bare metals from this, from the networking standpoint and from the standpoint of, well, the entire system. Once we've done that, we're going to enroll that hardware, and we're going to follow through with all the other steps that we've previously mentioned. And then we'll have a look at testing them and then running through some monitoring and logging, provided time allows. So let's not wait any longer. So first thing, when everyone has managed to log in, please set up a TMUC session, especially with the internet. I mean, so far it's looking quite stable, but let's make sure that we have a TMUC session running so that we don't lose our session. Once we are all in, we can have a quick look at what we have within our directory. We should see that we have that deployment directory. And the first thing we're going to do, you should be able to follow along on your worksheets that you should have found when you've scanned the QR code or used the URL. The first thing we're going to do is we're going to run this configure local networking.
Yes, this is just setting up access so that our seed VM will be able to later reach the controller nodes and the compute nodes.
And a fair bit of warning that this isn't a persistent change to the local networking, and if you're for some reason disconnected or you lose your session or you decide to reboot, you will need to rerun this, but there's no harm in running it multiple times. Has everyone managed to get access to a VM? I'm going to assume, yep. Yeah. Matt, do you want to have a... Again, the way that we like to run a lot of these sessions is if someone does have a question about anything at any given point, please do shout out. It's not a strict class or anything, and I think at the time it's probably the most appropriate time to tackle those questions. and can usually open the floor up for some very interesting discussions. So if at any point anyone has any questions or concerns, please do just shout out, raise a hand, whatever you like to do to get my attention, throw a piece of paper or paper airplane. So first thing we're going to have a look at is we're going to have a quick look at the current state of those virtual bare metals. So we're going to have a quick run of the sudo virtualist all. And we can see that we have the seed, the compute, and the controller. The compute and the controller, as previously mentioned, are turned off. What this looks like from the perspective of Bifrost is if we jump into the seed, you don't need to do this part. It is included in your worksheet if you wish to do it. These virtual machines will stay up for a little while, so feel free to continue these or retry them later on or at a later date. But if I SSH into the seed, a little bit wider, we can see that we have the compute and the controller both still powered off, and we have a bit more information about the provisioning state and whether they're maintenance or not. Now, this is just what Bifrost can see, and this this is something that is just going to be automatically detected by Bifrost because it automatically searches for any hardware that it can connect to. Then next thing we need to do is activate our working environment. There is a bunch of environment variables, and what we're going to do to source it is by looking at this, by running and sourcing this nvars.sh. We can have a quick look at it before everyone feel free to run it. I'm going to quickly show you the contents of it. Matt, if you want to talk about what the contents contain.
Yes, so I'll wait for Max to open it and I'll talk about it line by line. So it's just a little bash script. It sources this activate script from the virtual environment. So this is where KOB has already been pre-installed along with the dependencies of KOB. Then next line down, we activate the environment within KOB config. So this exports a few different environment variables to just say different paths of where configuration files are located. Then we source KOB complete. This is just bash completion, so you can tab complete all of your KOB commands. And then finally, we change directory to the very important directory here, KOB config etc KOB, so you know every change you want to make is below you.
So I'm now going to source that. Fun time. And we just want to verify that we have got the correct environment variables and that we actually have KOB pointed to the correct executable. So we can test that with a which KOB, and then we want to echo the KOB config path. We can see that is pointing to our current working directory, and so we know that the config that's going to be targeted and what the targeted endpoint for our cloud is supposed to look like will be dependent on the config that's defined within this directory. So now that we've done our pre-checks and housekeeping, we need to have a look at enrolling our hardware so that we can actually then turn it into a cloud. So the first thing that we need to have a look at is making sure that KOB is aware of the inventory that it's going to be managing and that it's aware of what it's going to be targeting. Now, luckily, there is a folder within the config called inventory. We can look at the contents. There will be a list of hosts and a set of group variables, and then the groups through which those hosts are within. As you can probably tell, there isn't very much else in there. Usually there's a definition for a few sets of groups or groups of hardware. Primarily, something that you can probably see in the commands on the left-hand side is that there's a mention to overcloud, but we don't actually have a definition for overcloud in the inventory. And that's why we are firstly going to do an inventory discover, because we actually need to populate and tell KOB, when we talk about the overcloud, what machines are we actually talking about.
Yes, so the inventory discover will be reaching out to Bifrost, the standalone version of Ironic, and essentially reading which nodes are already enrolled in Bifrost and converting those into an Ansible inventory.
Now, yeah. Sorry? So there are a few ways of configuring how we want to deduce discovery. So within, if I just quickly source, there is a file in this case called overcloud.yaml, which will have a set of ways to define hardware that it finds. In this case, because we have set it up using a virtualized bare metal, and we know that the names of the two nodes are going to be called controller 0 and compute 0, we've said that when it finds a node called controller 0 and compute 0, it should map them to a group called controller and compute. There are also other ways of doing that. You can have it as the default so that whenever it picks up any hardware, you can say allocate it directly to controllers, or you can set up other patterns for it to detect it.
As far as the actual discovery and enrollment into Bifrost, in this lab machine we've already pre-registered them. Actually in a more production-like environment, there's two methods you could use. One is an auto-discovery in Bifrost, so you would pixie boot the node and there would be DNS mask running in Bifrost handing out DHCP requests, so it would be able to reach out to nodes that make requests for an IP and then install an agent on the node to register it into Bifrost. The other method, if you're handling a lot of nodes all at once, is you may want to also pre-register those nodes. We don't cover it in this lab, but KOB has upcoming support for registering en masse from an inventory.
So once that's finished running, we can have a look at the contents of inventory again, and we can see now that we have a file called overclouds, and that is now our definition. So whenever we tell KOB, please can you operate on overcloud, it should target whatever is in the contents of this. So we can have a quick look inside, and we can see that we have the IPMI addresses for those two nodes and the nodes that it previously was corresponding to by its name. And you can see that they are grouped within the compute and the controllers. Next thing we need to do is gather the information about this hardware and actually deduce what makes up these nodes, so we are able to actually, when we run services or ask for a configure, it can determine what is best suited for it depending on what components make up this hardware. So to do so, we will run an overcloud hardware inspect. Again, the way that KOB commands are built is quite a repetitive pattern, so it gets quite simple to very quickly learn. If there was something that you wanted to do, an operation that you wanted to conduct, you can start configuring those yourself by slowly building up the knowledge. But Matt, if you want to go over the pattern whilst we get the hardware inspect underway.
Yeah, so the general form that KOB commands take is you start by calling KOB, that's the easy one. Then you would target a group, so we were using seed beforehand in examples, now we're targeting our overcloud. Then you follow up with the resource, the part of the group that you actually want to target. So there might be a host, there might be the hardware itself, there might be sorry, and then we go on to the action that you take on it. So there's like a discovery and inspect here. Later we'll also see there's you configure the host, so you deploy services on those hosts. The inspection itself, just to give a rough idea of what's going on here, is essentially pixie booting our nodes, and that they're going to listen for Bifrost to hand them out a little RAM disk that has something called the ironic Python agent in there. This handles then communication between the nodes and Bifrost itself. And what that's going to do is essentially look at the node, gather a load of information about the hardware, and then send that back to Bifrost, so it's able to populate information on the nodes so it knows how to later provision them with an operating system.
And what you're seeing on the top half, just above the playbook running, is the actual console from the compute node as the inspection is going on. So at the moment, we are waiting for them to be inspected and reboot. And so that's why nothing is currently going on in there. And after a while, they should both kick back up, and we should see it continue and then spit out all the information that we could possibly want about these two nodes. And then that will be stored, and then that's something that KOB will be aware of when we do any further actions, reporting to the set of nodes to that group. So whenever we refer to, for example, the compute group, if there were, let's say, a few hundred nodes on there, it would know everything about each of those individual nodes, but also make sure that the right version of everything is installed on the individual nodes. So another layer that you don't have to worry about because it's all handled by KOB on this side.
This does take a couple of minutes to run through, so if anyone's got any questions or anyone is stuck, yes, go ahead. Yeah. Yes. So when we come to running the host configuration, it is possible to add in additional playbooks that can run more setup on the nodes. We briefly cover that later, but yes, we do actually use KOB to enable VFLAG on the host for SRIV. Yeah. Yes. The top log is looking at the logs from this thing called virtual BMC. So it's essentially showing you the output of the actions that have been taken in the bare metal controller. Where? So VBMC is running on your lab machine itself. There is a command near the top of the worksheet, which you can, it's just a PS command to show what processes are currently running on the host. You will see one there, grepping for VBMC and showing you the ports available. This is essentially the magic layer in between that's letting us treat these virtual machines as though they're not virtual. Like that.
Ta-da.
Do you want to show the console logs as well on the controller?
Yep. Oh, was it? Yes.
Yes, go ahead. Yeah. Got an error. Oh, okay, I'll come up.
So now that we've come to the end of the inspect, we can have a quick look at what has been spat out instead of we can see that all devices that are attached to it, as well as the information about its current setup, including all the hardware that's attached to it, is described within here, and this is what's passed on during the inspect. If we now actually have a look at the state of our instances with the sudo versh list all, previously if you cast your mind back, we'll probably remember that they were all, well, two of them were shut off and they weren't active with just a seed. But if we run a sudo versh list all, we can see that all three of them are now up and running. But from the perspective of Bifrost, what does it actually look like? As previously they were in just an available state without being under maintenance with no instance UUID. It was just aware that they existed but didn't have any information about them. So we can run this again, and we can see that they have gone from being powered off to on, and the provisioning state has gone from available to manageable. Now that means that we can actually look to apply changes on the operating system level in terms of even just installing an operating system. It is in a state where we can turn it into a machine from which we can do extensive changes to, in this case, enabling it to become part of our OpenStack cloud. Again, if anyone has failed at this, failed the inspection, it could be worthwhile just to double check that your inventory has been populated with the overcloud. And if that is still failing, it might be worth to rerun the configure local networking. Again, sometimes rerunning that can clear up a few things. So now that we have our hardware enrolled and inspected, and so therefore we know where it is, we know how to communicate to it, and we know what it's made up of, the next few steps is just exactly like we were explaining in the steps where we were like repeating the same, like the 5 key steps. This is where we're going to go back to, and so we need to look at installing an operating system and then configuring it so it's ready to run containers and therefore run our services. And then when we can have all those running together, let's get the containers on there, let's get them running, and they should all be ready to communicate with each other because all that would have been pre-configured with the host configure. So first thing we're going to do is let's start installing our operating system on there. Again, this is something that you can tweak in the KOE config. And again, a lot of these we have just previously set up or set up for in advance. However, again, absolutely everything to the nth detail is configurable or customizable within KOE config. And what I'm going to do whilst this is running, I'm going to quickly open up and follow the console logs for the 2 machines. We deployed these virtual bare metal machines with something called tanks, which stands for 10,000 spoons, which is a bit of a far-fetched joke internally because it was actually named that because of Alain Morissette's song Ironic. I wanted to do a solo sing-along, but I've been told that there's Geneva Conventions against that. Oh, so if you want to have access to Bifrost, you SSH to the seed, which is this. I'll show you the IP address. You would just need to go to 192.168.33.5. Once you've SSH to the seed, you can run a sudo docker exec to execute a command -it for interactive, and then the container is called bifrost_deploy. It does have autocomplete, so tab will do that, and then the command at the end bash. Once you have entered the Bifrost container, we need to define which OpenStack cloud the command needs to target, and that can be done by running an export os_cloud and then saying that equal to Bifrost.
There's a section in the worksheet, exploring tanks in the seed. It has those commands in there. Yeah. It's all right. I think it's a bit further down than this stage of the instructions.
So let's quickly tail along with the console logs.
Yes, go ahead. Yes, so you can, when you're doing the inspection, you can also run a few benchmarks and gather a lot of additional data. And then you could use some additional tooling to actually compare that data to each other to detect like anonymous information. We actually have a little script which I've written to visualize these anomalies as well. It's called Advise, stands for the Anomaly Detection Visualizer. We have that up on GitHub. It is also quite common if there is more serious hardware faults that the inspections will fail. Ironic, Bifrost is quite good at giving back a helpful error message as to why it failed. It might say something like, couldn't detect the disk, and that might mean there's something wrong with your storage. Or if it couldn't connect at all, there might be something wrong with your networking connections.
So hopefully everyone by now has finished with their provision. And in the background, I had the console logs showing from the actual bare metal itself what it looks like. And you can see it went through the standard procedure of installing an operating system, then booting up, and then when it boots up, looking for that login. And then that's when we know that we are good to go and continue. So now we have our operating system, but we have nothing installed on there. We have nothing configured, none of the networking. So we need to actually get all that configured. Again, I would, just for safety, I would rerun the configure local networking host script. There's no harm in running it multiple times. So I'm just going to make sure that is done. You can do it from this directory. You can just copy the command that's in the worksheet. And then from here, we're going to run our KOB overcloud host configure. We're just going to close that completely.
So this is one of the largest commands or largest sets of playbooks that KOB runs in one command. What this is essentially doing is all of the configuration on the host needed to then be able to target it with collar Ansible. So we can see as it's going through here, it sets up a Python virtual environment actually on the host that you can then call commands on the host from. And then we'll see it install various other packages required for running the containers and configuring other parts of the hosts. At this stage, it can also set up host-level networking. This is all defined and highly customizable in the KOB config. You can see that happening now.
What I will also quickly do at this point is I'm going to quickly SSH into one of those and see if we can catch any of the changes as they happen. I didn't manage to beat it, but the stack user, you probably saw me half typing stack and then deleting it and then typing again, then re-deleting it. That's because by default, across all the nodes, the stack user is what is created, and that's what will be used to often manage those individual nodes. And so one of the first things it does is it sets up the stack user, and it is from there that we then expect KOB to SSH into the individual nodes and make those changes as it does. And the other things that we would be able to see that change is the state of the networking, usually starting with a very basic setup. And obviously, in this case, we are having a very basic setup because we're running an all-in-one deployment. But we still have some of the virtualized bridges and for the Ethernet. So at this point, we should be towards the end. There we are. If anyone's wondering about the colors when it comes to deploying these playbooks, for the most part, yellow is very good because it means that anything that you have changed has been applied. Very scary color if you've made no changes, and obviously red meaning bad, but you can somewhat ignore it if the playbook hasn't stopped. As we saw previously, there was a bit of red, but that's just because one of the system D units wasn't running, and it was fine without it because it kicks it later. But if it goes red and it stops, then you worry. Is anyone having any issues with the host configure? Matt, would you go? So from what I ever so slightly overheard, because it's actually a really good point, is that you'll see quite a few of the playbooks will have parts where they will be in grey or in black text saying retrying or failed retrying. That is just usually because it's waiting for something or for a service to start, or it's waiting for something to boot, in which case don't panic, it's not in red. If it wasn't red, panic. If it's red and it breaks and it stops, really panic and ask him. If he can't fix it, you just burn everything and destroy your laptop. You never were there in the first place. So the next step is the second longest step, and it's quite an important one. And this is when we're going to be pulling in our containers for our services, and once we pull those in, we should be able to see that we go from having no images on our control and our compute nodes, and we're going to see that it's going to be full of them because we're going to pull them from our registry, in this case our seed, and then we're going to actually tell KOB, can you please run all the appropriate services on the appropriate hosts for us, please, and get them all connected together so they can all work together. So we're going to start off with the image pull. Once again, at this point, I'm going to SSH into the compute. In fact, I might even go into the controller. I'm feeling adventurous today. Why not? And this time I can use the stack user. So I will SSH into 192.168. There might be 2.
So just to explain a bit more why this is a specific command, it's very helpful to pull the container images in first, because at production scale you could have quite a lot of hosts all at once. So if you, and we don't really want to be pulling those images all just on demand. You can run this in advance. Say if you're going to be doing some maintenance on your system, you can run it the night before. So when you actually come to have a change window, you limit the amount of time you need to just wait for things to download.
Yeah, this was all built with keeping in mind user experience and maintenance, and no one likes to have downtime. Even if you explain to them, this is because this will save you a lot of grief later on, they don't care because they want to do their work right now. So yes, being able to pull those in earlier is very, very useful, and won't disrupt any of the running services as they currently are. I quickly did a Docker image ls, and you can see that there are a few images that have been pulled in that meantime. I managed to catch it in the controller with only one, but hopefully if I run this now, we can see we pulled in a fair few more for the various services we're going to be running, and the same should be shown here. I will also run a Docker ps, which will show any running containers, or in this case any running services through the containers.
And this is just to to hammer the point home that there's no containers running yet. It's just pulling in the images in advance.
And if you were probably thinking, hey, I've asked Kobe to run some services for me, but I forgot to pull in the images. Oh no, what's it going to do when it realizes that the containers aren't there? Not to worry. It's actually self-aware of it. It will check, and if it sees there's no container for it to actually run, it will try and actually pull that in. So a lot of the time, you may not even want to run a container image pull. It does speed things up, but it's one less command you need to run. And I think it makes me feel a lot better at my job, because it's like, hey, I did it with one less command. How efficient. So you can just run a service deploy with none of the images pulled in, and it will pull those in for you and then automatically deploy them. But as Matt mentioned earlier, if it comes to upgrades for clients and we're pulling in newer versions of those containers, better not to just run a service deploy blindly, better to pull them in one by one, and then just make sure that you can service deploy nice and calm, knowing that everything's there. This will take a little while longer, and then we can get started immediately on the deploy. If you have managed to pull all images in and you're at the end, please feel free to run a KB over cloud service deploy. And as you can see so far, we are actually getting to the point where we will have a cloud running with all the services that we would need to have a functioning cloud. And what's it taken us? Maybe 6, 7 commands. And provided the gods are on your side and you're doing this with bare metal in production, if you have 0 errors, you can deploy to production in about 7 commands. But again, does anything ever run the first time? When he runs it, it does. When I don't. When I do, I don't. So I'm going to go straight into a KB over cloud service deploy, and Matt, if you can talk about how good all the different services that they are popping up are.
Yeah, so this is the fun command. This is where KOB actually starts talking to Collar Ansible. So it's essentially calling the same underlying Collar Ansible playbooks as before, but this time with the flags changed, so it will actually say deploy the containers as well as just pulling the images in. On top of that, it also copies in configuration files for each individual OpenStack service. These can all be customized and overwritten by KOB in your KOB config. And KOB does also have some opinionated configuration already in place to make your cloud setup in a way that we think it works more smoothly. It's not just OpenStack services that are being deployed. Collar Ansible also ships accompanying other open source services that are used to actually allow the whole cloud to run. Things like MariaDB, RabbitMQ.
So
yes. Yes, you can. Yes, you can go back. Because Bifrost is a standalone version of Ironic, it has the full machine lifecycle management in there. So there is a command KOB overcloud deprovision that will essentially just shut down the machine and take the operating system off of it, and then you could just provision again and start from scratch. Often, you won't even need to do that though. Because we're using Ansible for configuring it, we can utilize how it is idempotent. So every time you run, it will only make changes if it needs to. So if you find, for example, you've configured a service wrong, you've misspelled something and the container's not starting, you can just go fix your spelling, run the deploy again, and it won't touch all the containers that's already deployed. It will just update the configuration on the one you've made a new change to. So it's often more a case of iterating on your changes in KOB config and rerunning the host configure or the service deploy until you get to a happy, healthy cloud. No.
yeah, just to hammer that point home as well, we've had a situation where we were doing a service deploy and configuring some brand new machines and adding them as part of an expansion to someone's already large cloud. And during the process, one of their nodes went down completely during the service deploy and host configuration, and turned out I asked, where's it gone, this node? Can you go and check it, see if it's plugged in? Can't talk to it. He says, oh, it didn't seem to be plugged in properly. It turns out that this network card is hot swappable. It isn't. He just ripped it out the back. And to which he went, oh no, this isn't good. Managed to plug it back in, get connected, ran the same command again, and it just picked up from where it left off. Everything else checked. It went, yep, we've already got services running. We're good. We're registered. And it noticed that this one is like, oh, this one was dropped along the way. We can talk to it now. Brought it up to speed, and it was exactly where everything else was.
Yes, go ahead.
I do understand the advantages of running the service in containers.
Mm-hmm.
But what about the persistence of the databases? How do you take care of that? Is it also incorporated in the containers?
Yes, so we have Docker volumes that are deployed alongside the containers, and the databases are stored in there. We often configure these to be in a separate LVM partition, so the data is written separately from your logs or your host services. So if, for example, you suddenly have your monitoring goes out of control and fills up all your file system, it shouldn't touch your database or your other critical services. KB also supports, through Collar Ansible, backing up the database, so it will write it out to a separate file that can be exported elsewhere. In the lab? Yes, there is documentation for both of those, for both how to do a backup, and there should be documentation for how to configure LVM as well. Yes, go ahead. Yes, you can. So we had, I briefly mentioned this earlier, but there's a concept of environments in KOB config. You could define each cluster as a separate environment, so this would just have its own inventory with its own set of IP addresses for how you access it. And then when you go to source your the KOBN script in the KOB config, you just add an environment flag, and this will let you choose which cluster you're targeting. This also means if you define configuration in the base environment, it can be shared between both. Of course, you would need to be able to reach both those clusters from the same control host.
I put a scary image of what it would look like.
That is a scary image. Yeah, the environments at the top, you can see essentially, you could have a configuration defined in your environments that would either target a single system or can be shared between both of them.
If you're wondering what all these colourful lines going backwards and forwards are, it's just showing that when you're calling for deployment 1 in the environment or deployment 2 in the environment, it will overwrite whatever the default in the base environment is. So you don't need to redefine the entirety of the KOB config in each of the environments. You only need to define the bits that you want to overwrite or the bits that you want to make unique for each deployment, and then you can just tell it when you source your envars.sh, you just say, hey, I want to use this environment, and so when I deploy, I want you to target only this config, and then it will take the base and overwrite anything that it takes from that environment's name.
Yeah, as a more concrete example of what you might share and what you might not, you would often share the services you want to deploy. So I want to deploy Nova, Neutron, so forth. But networking configuration might be more different. You might be running different physical network cards, so they show up in the machines with different interface names. So you would define those per group or per host within your separate environments.
Is everyone still running service deploy successfully? And okay, cool.
Yeah, this command takes a fair while to run, so
it's always a good time for questions and discussion. But just so that we cover all bases, we have previously been talking about, yeah, it's running certain playbooks, and we keep talking about it's running a playbook, and the playbook's doing this, and you're not limited to just what has been defined in the base set of playbooks or even what we've defined in our own playbooks. You are more than welcome to write your own playbooks and integrate those. And as such, those playbooks can be stored within your deployment. You can also store them specifically in a specific environment. To where they live within the config itself, I'm just going to quickly show you within the KOB config etc KOB, there is an Ansible directory, and this is a fairly empty one, but this is where all the playbooks will live, and within those roles too. And it's within here that you can add your own custom playbook, and so that when you tell KOB, can you please run this playbook, it knows to look within this directory.
Yeah, so this is the question earlier about whether or not we configure SRIOV with KOB. Right now, it's not a built-in feature in KOB itself, so when we configure this on our sites, we have hooks that run those additional playbooks and scripts to do so.
And funny you should mention hooks, because a lot of time, well, we would hope that everyone would have a deployment where everyone's working from their own clone of the Git repository of your KOB config, but sometimes what happens is everyone works from the exact same one, all dogpiling on top of each other. It's terrifying to see, even more terrifying to know that prod runs like that in some cases. We do not recommend it, but people still do it. But sometimes you'll have your own playbook which fixes a bug. In some cases, you may have to kick a certain bridge every time you run a host configure. You may need to have a certain playbook run for centralized logging every time you do a host configure. And remembering to do that every time is not only arduous on your side. If a new engineer comes along or someone says, hey, can you please go and fix and have a look at that one node that's not acting correctly, and you go, okay, yeah, I'll go and have a look, and they run a command, but they don't know to run that special playbook, and all of a sudden it's broken and no one can figure out why, apart from the one engineer that's gone on holiday. I'm not saying this because this has happened to me personally, it just hurts every time it does. What you can do is you can tell it in advance and permanently that every time you run a certain KOB command, whether it's before or after it, you can tell it to run that playbook. And we're actually going to have a go at that in a minute. So I'm going to have a quick look to see if our service deploy is still going, very persistent. We can have a quick look to check, though, if we have any services currently running. Hey, look at that. On the compute, we have a fair few up and running. As you can see, 10 minutes ago we had a few started, and 7 seconds ago. So it does take its time. The time is required for it. There are some fairly neat things you can also do with the hooks. Matt?
Yeah, so you may be wondering why we even have hooks at all. Why don't we just take every feature that we develop and get it back up into KOB itself? And from my perspective, the main motivation for that is there's often things that are quite site-specific. You might have a fix or a feature you want to apply that's just special for your environment because you have some weird hardware or something like that. An example at one of our client sites I like to give is we were trying to set up hardware offloaded networking onto their Mellanox ConnectX-6 network interfaces, and we were seeing it worked perfectly fine between hypervisors, but the moment we tried to connect out to the internet, there was just no connections at all. And this is because we also had Broadcom NICs in these hosts, which also advertised that they enabled hardware offloaded networking, but we hadn't actually set it up to work. So OVS was detecting, or maybe OVN, I'm not a networking guy really, was detecting that it should be able to offload here, so it's trying to offload all of the north-south traffic and failing. So we have a hook at this site that runs post the host configure to disable the the offloaded networking flag on the Broadcom NICs. Yeah.
The other thing you may be wondering is, what if we had multiple that have multiple playbooks that need to run one after the other or in a very specific order? And generally, that is done by the playbook's alphabetical order. However, that is somewhat tricky if you're trying to come up with very creative names for every single one, but you can order them numerically, starting from whatever number you want, and then if it's a higher or lower, will determine whether it's run before or after the previous one. Now you can be really nice and start from 0 or 1, then make it count up or down and move away from that. Or you can choose your own incremental pattern, be crazy, start from a random number and really confuse people as to why you started with random numbers. Funny enough, it's actually quite a good idea to start with a large number, around 50-ish, because it gives you plenty of space to put things beforehand without having to rename 10 other playbooks, and instead you also have space above it. So that is a way of organizing those hooks.
Looks like we're just coming to the end now. Here we go. So that's all of these services now deployed on the host. So we have a cloud.
Yep, by default at this point, this is actually where you would be able to deploy a virtual machine, and you should have all your services up and running and talking to each other. So we will have a quick look at the state of the cloud and all the services running. And we can see that all of them are reporting healthy. If they weren't reporting healthy, it would also say that it was unhealthy or failing startup. So anything that doesn't report not healthy, it's still okay. So I think at this point, it's time we actually look at doing some more intricate, beautiful things. And I think you can start taking. I think it's your turn to do a bit of work, So Matt right now is going to quickly jump into the TMUX session, and he's going to walk you through setting up a hook. We have a playbook that we will want to run, which runs FluentD, and the FluentD will actually help with centralized logging, as we are going to hopefully have time for some monitoring and logging. So you can run it manually, or we can create a hook for it. In this case, this hook is going to make sure that we run it every time that we run an overcloud host configure. So if you want to set up your own hook, it is really quite simple. You just have to already determine which KOB command it is that you want it to run before or after. You make a directory with that name to it. So in this case, we have overcloud host configure, and then in that directory itself, you want to have postd or pre to whether you want it to be before or after that command. And then, yes, you can hard code the playbook within there, or because we already know it should exist in the Ansible directory within your KOB config, it is often much better just to use a symlink, because it then treats it exactly the same with only having to use the one playbook whilst they all live in the same place. It'd be very confusing if it's only in one. If you have half of the playbooks in your Ansible directory and some in your hooks.
Yes, so I've just symlinked this into this directory here. So we can do a SLH here. We can see this is pointing up to this Ansible directory where we have a playbook. I've changed directory, haven't I? There you go. So this playbook is just an example of something you might want to do with a hook. This is taking the actual logs on the host itself and passing those into FluentD for later being able to be read. But we'll come on to that. So if I were to now run an overcloud host configure, this would run automatically afterwards. But this took a fair amount of time last time, and we're a bit time limited now. So I'm just going to cheat and run the playbook just directly.
you can all feel free to do the exact same. The command being Kobe playbook run, and then pointing to the actual playbook that you want to execute. That is the kind of like the step for running any custom playbook. So again, you can specify the target or even define within the playbook itself which groups of hosts you want it to target. So in this case, Matt just ran the playbook, and you can see it's already targeted the compute and the controller because it was the overcloud that was defined.
Yes. So at this stage, you might be thinking, this is all well and good. I've deployed a cloud, but now my users have come in and they've said, we want all the shiny new stuff. Why have you just given us a core OpenStack? So let's run through some instructions on how we could actually deploy additional services. In this example here, we're going to deploy Grafana and Prometheus to add some support for monitoring and logging. So we have, let me just find myself which direction we're in. So within our KB config, we have this one file here, collar.yaml. This configures essentially everything for what collar may be deploying services wise. So around about here, midway through the file, we have a whole list of every single service that collar supports that we may want to deploy. And in this case, we're explicitly going to enable Grafana. Forgive my poor Vim skills. I'm much more of a VS Code kind of guy. So we'll enable Grafana here, and we will enable Prometheus.
Now you may see that there are loads that share the same name, or some services which have very odd names that don't seem to point to any service, and that's because in certain cases, for example, there's one called centralized logging, and it's those themselves actually contain and will set up multiple services at the same time, because a lot of them will be required to run together in order for those services to actually work. So for centralized, for central logging that we can see right there, that will actually deploy quite a fair few, including OpenSearch and a fair few others for gathering logs and time seriesing them.
Yeah, specifically it's OpenSearch and FluentD. So FluentD scrapes all the logs from the hosts and pushes them up to OpenSearch. This is incidentally what we were extending with the hook we ran earlier. We have defined to enable Grafana and Prometheus, but these services are actually designed to be deployed on a different subset of hosts. They wouldn't normally run just on a controller or compute node. You may have a separate set of hosts for monitoring. Not always, sometimes it runs on controllers. In this case as well, we're going to use the controller node as a monitoring node. So there is another variable in here called collar overcloud inventory top level group map, which is very hard to say even once. So what I'm going to define here is essentially I'm pasting in the default values we already have and then adding a new monitoring group for us to define where the monitoring services should actually be deployed. So here I've just all these up here, the defaults, so the control nodes go to controllers, your network nodes go to networks, so forth. We want our monitoring nodes to go to our controllers too here.
Again, you'll be able to find what he just pasted in your worksheets, so don't try and type that out, but be careful with when you're pasting the indentation, making sure that you are using the correct indentation. Yeah, I guess the next step is how do we actually get our new shiny services up and running?
Yes, so if you were doing this on a production system, you would probably have a maintenance window for when you want to deploy new services. So you would likely run the KB overcloud container image pull. I want to show off what we were talking about earlier though, and prove the point that if you have a small system, a staging system, a test system, there are some commands you can skip to make your testing quicker. So we'll just run the overcloud service deploy here. We can also limit further. So if I were to use collar tags here, this will essentially pass a section of tags into the Ansible for collar Ansible, so it will only run specific playbooks. It just speeds things up a bit. So we're going to pass in the collar tags for. We'll pass in common to make sure that the core services are configured. We'll pass in load balancer. This is so that there's a session of HA proxy deployed that balances between hosts when you have multiple hosts. And then we can pass in our new services that we actually want to deploy, Prometheus and Grafana. And we'll see if I've remembered these correctly, because that's off the cuff here.
The other thing that you may be wondering is, okay, I can limit just to those services, but what if the changes I'm making aren't related to collar and any other services? What can I do with these tags? Well, there's also just limit and tag, for which you can then specifically limit to which hosts you want to target with certain changes or certain playbooks. So for example, earlier when Matt used KOB playbook run, you can specifically set the limit to, I just want to run this against compute nodes, nothing else. And you can do that just by putting -L and just writing compute. If you want to specify exactly which compute nodes, you can. You put compute, and then you can put the variable inside for, you know, whether it's the 0th or the 1st or the 2nd or the last compute node, or specify the actual compute name. So you have a myriad of ways of defining which hosts you actually want to target. And with the tags, you can specify whether you want to target the group of hosts that actually would specify to that set or subset of tasks. So for example, you can have a tag for networking. So if you're making a change and you only want to apply it, the changes that you've made to your KB config related to networking, you can put -T networking and all the changes that are only related to networking and playbooks related to networking will run. So if you aren't sure if all changes that you've made are going to impact many things, but you know that you need to apply a patch for networking, for example, you can just specifically tag networking, and you can use them all in tandem at the same time. It seems a bit tricky, but they do become lifesavers at points, especially when you're trying to thread the needle with only changing certain hosts. So again, this will take a little bit of time, because in this case, we are not only deploying a service, we are also pulling in the containers themselves. And has everyone managed to get a second service deploy running? Or is anyone having any issues or any questions for Matt? Okay, so once we have our new services, we will be looking to see what we can do with those services if, for example, we have a client who wants something very specific to be done with those services. But I'm not going to spoil it. I'm not going to give any spoilers away. If there are any questions, please shout out. It doesn't have to be about this. Yes. The seed VM should just be left up and running, because Bifrost is integral to if you want to expand. There'll be it's always going to be under use, and in most cases there's more than just Bifrost running, and there could be other services running. In this case, we have the registry, so if we got rid of the registry, we wouldn't be able to pull down any images. Because for the most part, we build our own container images because we want to make sure they are version controlled, and we CI test them every night, just so we can make sure that whenever we deploy, we have almost 100% guarantee that it's going to work, because we've tested it every night, and so we use our own images. So if we got rid of that, we would be we'd have to spin up a new one every day.
Yeah, it is worth keeping Bifrost specifically around as well, because you might find or you probably will find that at some point you want to upgrade the operating systems that your hosts are running, and you don't really want to go through the whole stage of having to re-register or rediscover your nodes in Bifrost to re-provision them with a new host image. So if you just keep the seed running, it's fairly minimal when it's not being used, like resource-wise, and it just yes. Yeah, when we come to upgrade, we'll actually be coming soon to upgrade our sites from Rocky Linux 9 to Rocky Linux 10. We will deprovision the hosts in turn using Bifrost and then reprovision them with a new Rocky Linux image. Yeah.
During the deployment with KB current similar, is it better to first try configuration with current similar than to implement with KB?
Might be a bit biased here because KOB is a service we offer, but I would say no, because KOB is using Collar Ansible anyway. So if you have a system that is already set up, it is possible to customize your KB inventory to target an existing system, and then you would just be able to essentially use KOB to run Collar Ansible already, and that would set you up in a good position to then be able to use KOB afterwards. If you're still up in the air about whether or not you want to use even Collar Ansible at all, it could be helpful to start with Collar Ansible on like a testing development system. Our colleagues actually ran a workshop yesterday about starting from scratch with Collar Ansible. I think those resources will be made available after the conference if you're curious. But yeah, from my Stack HPC company perspective, it's worth starting with KOB, but I can understand if you want to just get in with as small as possible, Collar Ansible could be useful, yes.
So we are slowly approaching the end of the second service deploy, and I promise you this will be the longest set of commands that you will be running, but of course the alternative is to run this manually and do it one by one, which will take a lot more time and your hair would get grey very quickly. As all these senior engineers that used to do that at our company are, well, short of hair. Don't tell them I said that. I like my job.
One thing I can point out while we're still running here is this configure local networking script that we have been running. One section of this is exposing ports for different services. Somewhere.
There, just there.
Here, yeah. So we have a section of ports that are made available. This is mainly designed for just the core services. So we have port 80 for ANSYS Sync Horizon and port 6080 for the VNC console. We're now deploying more services that we want to actually be exposed publicly. So it will be worth updating this script to instead also include the ports for OpenSearch that's already been deployed, and for Prometheus and Grafana. There's a sed command we can copy from the worksheet to make sure that all of the spacing and whatnot is correct. So if I were to open it back up here, we can see now this list has been expanded, and that's just used later in this script. This script is just a resource for the lab. If you were doing this on a proper system, you would probably have some sort of firewall for managing which ports are actually exposed, and then you can configure your networking using KOB to expose it on the correct VLAN and such. So I'll just give that a run.
And that's also another, another very good reason to have a set of different working environments, in the sense of having your KOB config and then having the environments for each set of deployments, is that you can obviously then define the firewall per environment, which means that again you can fine tune and fine control as many environments as you want, all just within one KOB config, which is just one repository on whichever Git hosting service you prefer to use. And that does mean that for larger institutes, the actual maintenance and the burden of working on such large systems actually becomes quite trivial, because the amount of change that you'd need to make per environment is actually minimalized, because of the fact that anything that crosses over, or any of the definitions for variables which are shared, can be defined in the base config, and only the very specific changes that need to be made need to be defined. So at the moment we have Prometheus container starting up, so hopefully the services should soon be done.
The reason this is taking a little while here is because this is the step where it's actually also downloading the image in. So it takes its time.
So yeah, if we cast our mind back to when we did the container image pull and then do the service deploy, we obviously did straight up the service deploy in this situation, and in this case it's doing both at the same time. Run them one and then the other can sometimes yield better times in terms of working to get them finished, but for convenience sake, just running the one service deploy is usually the easier way.
What time was this meant to end? Is it now? Yeah. I think technically we're at time here, but we're happy to keep going because I don't think there's any more talks going on. Also, I think we've been given permission to keep these lab machines running for a few days afterwards. So if anyone wants to, go through it in your own time, you're able to. Yes. We'll keep going through. I won't be offended if you guys have a bus to catch, but we don't.
I will make sure to take it personally in that case.
Right. I'll try and do some things on the side so we're not just sitting here staring at a playbook that's downloading an image. We say you may find later in running your system that you actually want to reconfigure the configuration for an OpenStack service. Here, as an example, we're going to reduce the CPU allocation ratio. You might want to do this if, say, you suddenly find that your users are actually using their VMs to their maximum capacity, and they're all complaining that when everyone else is working on the system, it's getting really, really slow. And that's because everyone's sharing the same physical CPUs because we've overcommitted the vCPUs. So in this case here, we're going to reduce it just down to 1, so you can't actually overcommit them at all. So these configurations are done under the directory etc kob collar. That is different from the etc collar. This is the generated one. We want to go to the one where we actually configure the services. So if we look under etc kob collar right now, you can see there is a config directory. And what we're going to do is add in a new file here called nova.conf, and this is to configure the Nova service. So I'm going to paste in some configuration here. Yeah? Yeah? Did I get it wrong? Okay, thank you.
I don't think they've noticed. Shit.
There you go, .conf. Thank you. And then we would come to deploy this using KBO Cloud Service Deploy again.
And it won't take as long.
Yeah, it won't take as long that time around because it won't need to download the images in. Don't know why that's taking so long, actually.
So this is just a lot deployment with single controller.
Yes.
In production, how do you use in production?
In production, you'd normally have 3 controllers.
Also Docker or Kubernetes?
We don't use Kubernetes, we use Docker.
Docker Swarm?
No, just Docker deployed with Ansible. Yeah. And then there would be, for the services that are clustered, we would template out configuration files using Ansible to actually point them to each other.
The application clusters.
Yes. Yeah, things like RabbitMQ or Galera for MariaDB.
And then depending on what other services, you can deploy Magnum as well to then use Kubernetes, and then you can deploy clusters with that. And but again, the flexibility for that is all within the KOB config.
Yeah.
So this is usually the part of the day where I would start calling Matt. Is everything running okay on my service deploy? I haven't broken anything, have I? To which Matt would come over and what would you do?
Well, in this case, you put me on the spot here. let's go have a look at the host and see whether or not the image is in place. And it seems it isn't. Oh, I'm on the wrong node. That's why. .4? Is that the controller? No. Do you remember the controller IP? .3. Cool. There's no images pulled in yet. It's not full, is it? No.
Has everyone else's service deploy finished running the second time? Yeah.
Okay. Let's check.
Configure local networking.
I'm wondering if maybe it's not been populated in the seed correctly. No, it's in there. This is the failing of a live demo. I think oh no, actually, never mind. I can see Prometheus server is there, Prometheus v2 server. It may just be being quite slow. At a guess, OVH Cloud probably are using overcommit ratios, and all of our VMs land on the same host, so they're all slowing each other down. Complete guess. But it ties in nicely to the presentation.
I think whilst this is running, we can have a look at demonstrating some of the services that are already running. So we can show Horizon.
Yeah. Did you want to take back over the testing, or do you want me to?
Oh, feel free.
Yeah. Okay. Cool.
You can just.
Yes. So. How do I switch windows?
Actually, yeah, no.
It's your laptop, isn't it?
I just remember that. Yeah. There you go. So whilst we wait for that to run, we already have some services which are up and running that we can actually interact with. So we'll have a look at using those in the meantime. So first thing you need to do is take note of your sessions, your VM's IP address, which obviously, if you're in the worksheet, feel free to go back to the shared Etherpad. And once you have that, you can feel free to open a browser and type in the IP address and you should be greeted with your Horizon login page. Now, it's obviously going to ask for a username and password, and there is one that has been created for you upon its deployment. And anything that is secrets related for your services or just for OpenStack in general, those will be found in that templated KOB config etc collar, and those should always be encrypted unless you really like secret rotations and upset people about why all their secrets have been leaked. So if we have a look at moving into our working environment, So going from kobconfig etc kob, we can have a look at the contents of collar, and within there we can see that there is a passwords.yaml file that will contain all the secrets to all the services you've deployed, whether it's Grafana, OpenSearch, or any of the other services like Prometheus. However, you'll notice that there is also a public OpenRC and an admin OpenRC. Now, these are the credentials for which you'll be sourcing if you want to run commands that will need to authenticate against OpenStack. And as we are trying to log in with an admin set of credentials and as the admin user in Horizon, we will actually want to have a look inside admin OpenRC rather than passwords.yaml. So from there, we can go into collar, look at admin OpenRC.sh, and we can see that if we were to source it, it would actually just export a bunch of variables, mainly where the authentication endpoint is, and the user, which in this case is admin, and then the password for OpenStack. And it is this which is the key value that we will want in order to actually log into our Horizon. So once you've opened that, again, if you're working from the kobconfig etc kob directory, go back a directory, collar, admin OpenRC. You should find the password there, copy that, and then the username, admin, password, and as the French would say, voila. And then from here, you would be able to see any instances that you're running. You're probably all very familiar with Horizon. If not, this is where you could use a web UI to manage the set of running instances or deploy new ones. So let's have a look at what is going on over here. Aha! It looks like it has actually managed to run. Has everyone's service deploys managed to run? No, we're still waiting. Sorry about that. But in this case, we have managed to deploy the new services. We will continue to move forward with showing what we can do. Sorry?
Are you showing the right Tmux plane?
Oh, please don't tell me you did it in a different Tmux plane. Ah.
Yeah, looks like it failed.
So that is one example of getting a failure where it has stopped the playbook. It will try and continue for the other working nodes. So if you have one node which, for example, someone's pulled the plug out the back and is now broken, it's not going to stop the deployment for everything else. It will try and continue unless there is a fundamental issue with the whole cloud itself. So in this case, it would have deployed anything that it needed to or configured anything on compute. It seems to have done it absolutely successfully. So we can actually see that one error has occurred on the controller. The issue seems to be networking. It was unreachable. At this point, I would rerun the configure local networking and rerun just a basic service deploy. But I think for the interest of time, do we want to just show the other things that are running, or do you want to rerun another one?
Well, we're already over time, so I think if we just finish this off with a quick demo that you can use the cloud itself.
In that case, first thing that we'll need to do is we'll open up we will need to actually set up a set of flavors, VMs, images, because at the moment we would effectively need to register those. So to do so, the instructions are in your your notebook, and we will just need to run the init run once, but you will need to make sure that the public OpenRC has been sourced. Again, that is found in collar and then public OpenRC.sh, and then init run once. They will both be using the admin user in this case. So
yeah, the difference in public and admin is essentially the endpoint it's looking at. So in a proper production cloud, public will be pointing to the endpoint that you actually expose to users, while admin is the one that the services themselves talk to each other on. In this all-in-one environment that we're using here, those are the same IP address, so we can source either one.
Yeah, usually when we run these sessions, per session we take about 3 hours to run through the training session. We were very ambitious and wanted to try and be a little bit generous by trying to combine 2 of them and doing it in an hour and a half. And of course, nothing's going to work perfectly when you're trying to show other people. It's always the case. But again, thank you for being here as we stay over time and keep going through this.
We can leave you off with an example of actually being able to deploy a virtual machine within the cloud that we've just set up in a bit more than an hour and a half.
So what we usually do is you would have two Python virtual environments. You have the one that you're working in for KOB, which is applying your changes that you make in your KB config, and then you'd have a separate one for executing OpenStack commands and for running any OpenStack-based commands in terms of whether you're querying or asking it to create floating IPs or creating new hardware, new virtual machines. And in such cases, this is what it would look like.
The motivation here is just using a new Python virtual environment so you don't have any conflicting package installs. Rarely happens, but has done in the past. So it's safer.
So from the init run once script, we'll have in our deployment directory, we can see there is a subdirectory called VMs. Within that, there is the KOB one, which is the one that is sourced by that nvars.sh. The one that we are interested in is the OS VM, which is the OpenStack virtual environment. And we want to bin activate. And then the next thing we need to do, because we're going to ask it to do OpenStack-based commands, we need to give it credentials because it's going to try and authenticate. Thank you for joining. It's going to try and authenticate, and it needs to have the password and username, in this case for admin. So we will need to source from the full directory. It'll be deployment source kob config etc. This is the tricky part. It's in color because it's templated out, and we can use the public openrc.sh. We sourced it, so now if I were to show you a print of my environment variables, if I was just nicely use n for grep OS for OpenStack, we can see that here we have all the variables, including the username and the passwords. And yes, if you had an account registered with OpenStack in, for example, we have a Horizon account, and you wanted to deploy it from your personal account, or if you're handing out accounts, this similar setup would apply to them, but with their usernames, their tenant names, and their own passwords. But there are more efficient ways of doing that, which can be exported via Horizon. So now that we have exported the OpenStack credentials, we can actually look to deploy an actual VM. So you'll find within your notebook that there is a set of instructions on commands for deploying that. I'm just going to steal the ones that I took from here. So we're going to be creating this one, and actually no, I will need to create some extra resources.
That should be fine, I think.
Yeah, true.
Yeah. We are over time.
Yep.
Pull on admin.
Yeah.
Oh.
There's a set, the commands that you'll have written down in your worksheet will correspond to the correct ones. I'm just going to quickly copy those. I'm going to make it look real fancy by typing it all out. So again, actually, it's actually a good point to start to briefly cover the structure of an OpenStack set of commands. Obviously, starting with OpenStack to call the write executable, then it is again the thing that you are wanting to target with your command. In this case, it's a server. VMs are referred to as servers, and then it is followed by the action that you wish to take upon that defined object. In this case, we want to create it, so it'll be OpenStack server create. And then you can start applying tags. Now you can use -h and it will list out a myriad of very useful flags that you can use. In this case, we are going to use a Cirrus image because it's nice and lightweight. The flavor is spelt the incorrect way. I will not be hearing anything about that. We're going to use M1 tiny, and then the key name, which is just a registered key pair for your SSH key. Key name in this case is going to be called MyKey. Barely know him. Then the network is going to be DemoNet. Again, this was all configured and set up when we were running the init run once. And wait, demo1. Now, what the wait command is going to do is it will refuse to give us back the terminal until it has finished running that command. And it can be good practice to prevent people from hurriedly just trying to run the next command when, for example, their server hasn't even deployed yet. So now we have a VM up and running, so we can do an OpenStack server list. So again, the entity being the server, list what we're wanting to do with it. Now I will also prove that this works by refreshing, and we can see that it is here. It has the key pair, and it is running, and then its IP address. But I actually want to show you us getting into it. So we need to give it a floating IP to make it accessible. Again, you'll have OpenStack as your calling command, floating IP as the entity that we wish to interact with, and we want to create it, and then the last bit is usually the name associated that you want to give it. So in this case, we want to just call it public 1. In this case, it can also just be the networking that you wanted to assign to.
So this is a network that's been created in advance called public.
Yeah. And then the floating IP address will be found here. In this case, we don't give a floating IP a name because its name is its address. You can also take its ID and you can refer to it that way. Now we need to attach this floating IP to our demo instance, and again it works by starting with OpenStack, and then we want to name the object that we want to target, in this case again the server, and what do we want to specifically do to that server, and it's going to be add a resource, that resource being floating IP. And once we have outlined this, we need to explain it, well, we need to tell it which server it is that we want to target for this specific command. In this case, demo1, and then we need to tell it what specifically it is that we want to attach in terms of which floating IP, in this case, the one that we've previously created. And so if we do an OpenStack server list, we should see that now instead of having just DemoNet, it has two IPs attached to DemoNet, including that floating IP. So now we can take that and we can SSH Cirrus at that address. Yes, and we are now in our created VM. Do we have time for anything else, or should
I think we should
go home?
Maybe we had a wrapping up slide or two, but we'll go through this quickly.
So again, we can refresh this and we can see that that is also on there, and then the key pair name with the public key attached, all visible on here. Ah,
Yeah.
it was there the entire time.
It was there, yes.
Um,
We can just skip through to
yeah, so in your worksheet there are the instructions on how to get up the portals for Grafana and for OpenSearch and Prometheus, but as we are extremely over time and we will encourage you to test this out with your VMs, and we thank you ever so much for your patience and for your time, and we hope you enjoyed it. Yeah, and
Yeah.
thank you from both of us.
Thank you everyone for joining and for sticking through to the end.
We do have a set of fully fledged sessions coming up in December, whether it's just for yourselves or for a group of people. We will have 6 sessions, and they can be customized depending on your interests or what it is that you're wanting to do. Please feel free to, if you want to register your interest, scan the QR code and follow the instructions on there.
I understand the Open Infra team will be helping distribute the slides for all the workshops after the conference, so you'll be able to get that link out from an email sent out by them, hopefully, as well. Yeah, we also have a final slide here referencing all the resources that we've been using today. If you want to try and recreate this on your own infrastructure, give it more of an in-depth play, figure out exactly how to become an expert. Thank you.